Alright, so this is the first episode of the science fair, I guess, chapter or series. But these are just a set of resources for you to give you some context about the science fair and what we're going to be working on throughout the year. So let's go ahead and get started. Here's some questions. I didn't write objectives because this isn't really content. This is just to give you some context for what we're going to be working on. So here are 4 questions that I will answer in this video. What do you get to do this year regarding science fairs? The first one. The second one is, how will this year's science fair project be different than what I've done before? What you've done before, rather. I should say it that way. What kinds of support will you get? And what are the limitations of your project? Sorry about going back and forth between you and my. But this is all about trying to give you some context for this year. So let's go and get started in answering this first question. What do you get to do this year regarding science fair? Well, let me scroll over to the right a little bit to answer this first question. So I'll do it in this color. Now let me pick a different color here. So the first thing that you get to do, that you do get to be involved in a science fair, and that's part of it. That is a requirement of being in an honors biology class. But there are a couple of things that I'll help you with throughout the year. So it is a requirement to participate and complete. There is a significant amount of or a significant portion of your grade that is made up of science fair and science fair assignments. So it is imperative that you get these assignments done in a timely manner, especially because they build upon themselves. And if you don't get one done in a timely manner, or if you get one done in a timely manner and are asked to make some revisions and don't get through that process very quickly, then you'll quickly find yourself behind and struggling at the end. At the end of this process. So there's a requirement to participate and complete. It is an independent research project, which means, and I'll put quotation marks around independent, because you will get some help from me, you'll get some scaffolding, you'll get some support from me. You may choose to work in teams, which I'll talk about in a few minutes. And of course you get some support from your parents. But the idea here is that you're driving this project. It's up to you to complete this project, to find the question you want to answer, to figure out a way to answer that question, to conduct that experiment, collect data, analyze that data, and present what you found. So it's a long process. And it is, I'd say it goes for most of the year. So we start right away at the beginning of the year, and it's near the end of January, so approximately end of January is when, let's call it the first round of data analysis and conclusions need to be done. Because that's when the school science fair is. So that's the school science fair. Now, when I say first round, I'm qualifying that because in case you move on, you do really well at the school, which would be fantastic, then you move on to the regional science fair. And as you move along through this process, you can continue to collect data, you can continue to analyze data, you have new questions to ask and answer. So you'll continue to update that record of your inquiry into the science process. So that's one thing that's that you can expect through the year. So there's a lot of work to do between now and the end of January. So there are some scaffolds. So we'll talk about that. But let's go ahead and move on to the second question. Let me just scroll back to remind myself what the second question is. How will this year's science fair project be different than what I've done before? Okay, so let's answer this in a different color. So how is this going to be different? Well, I don't really know exactly what your experience has been. Depending on what school you've come from, what community you've come from, you might have different experiences or different ideas of what a science fair project is. Well, so let me tell you a little bit about what this one is. Um, so we, as a school, have. Let's do this. We have a class science fair. If you do well at the class science fair, you go to the school science fair. If you do well at the school science fair, you go to the regional science fair. And if you do well at the regional science fair, you go on to the international science fair. Now, I'll tell you that ISCF stands for the, I guess I should write this, the International Science and Engineering Fair. So really what's important to know, the reason I'm telling you this is because if at the mid-January we'll have our class fair. If you do well, you go into the school fair. If you do well at the school fair, you go into the regional fair. If I remember correctly, it's in March. And then the International Science Fair, which is in May. And this year it's going to be in Arizona, I believe. So, but it rotates between Los Angeles, Arizona, and Pittsburgh. The reason I'm telling you this is because what you choose to do here at the class, for the class, needs to fit into the requirements for the International Science and Engineering Fair, which is run by Intel. So let me give you the web address that you can go check out on your own to look at what kinds of projects have been done, what the expectations are, and explore this site a little more. So let me get that for you. I'll jot it down here. Okay, so here's the website. I'll write it in this. So it's www.societyforscience, all one word. I know there's a space here, but it's all one word, for science.org/ISEF. And so really when we think about what you can and cannot do in class, if I'm saying that question is not possible, I'm not saying that your question is not a valid question, it's not a good question, but rather it may have complications or may not be allowed according to the International Science and Engineering Fair guidelines and rules, because they abide by a certain code of ethics regarding experimentation, as all scientists do. And so this is what I'm checking against when you propose projects to me. Okay? So this is the body that we really have to be mindful of, and that's really what we're operating under. Now, odds are very low that all of you will get to go to the International Science and Engineering Fair. There aren't that many spots from Fairfax County. But all of these different fairs lead up to this, abide by the same regulations there. Okay? Now, some other ways that this fair might be a little different than what you've done before. This is not a show and tell kind of fair. So you can't really do things that you did in elementary school or middle school. So you can't do the volcano project. You can't do the effect of different colors on plant growth. It's not a show and tell, and it's not an elementary or middle school science fair. If I walk into the elementary school or middle school and see a project that one of my students is proposing, then that tells me that it's not up to par. It's not to the level that we want. And really a good guideline here is that you need to find a project, or maybe I'll just frame this as a question. The question that you're trying to answer in your experiment. You have to do an experiment. Well, if you're falling into the science component, if you're falling into the engineering component, you really have to design something and test it. Okay, so there's a lot of data collection that has to occur. So you have to ask a question. Here's the important part, that you do not already know the answer to. Now, you might be asking, oh, that's easy. Maybe I'll act like I don't know the answer to that question. Or it's a question that you can look up very easily. So, here's the other caveat. Or cannot be found easily. So it needs to be some kind of a new question. New question for you. Something that you don't know. And the only way to answer it is by conducting this experiment. So these are the guidelines, and so that's why I ruled out the effect of color of light or the amount of light, the amount of water on plant growth. All that kind of stuff is out the door. That's too simple. You can find the answer to that. It does not require the kind of rigor that we're looking for as part of the science fair experiment. Excuse me one second. Sorry about that. That was my wife. Anyways, back on topic. Yeah, so it needs to be something new. Okay? If you have questions about that, be sure to jot those down and ask. Okay, let me scroll up. So this year's science fair will be different than what you've done before. So it does have to be a higher rigor. You will have deadlines throughout the process that you will have to put in time, quite a bit of time in to doing. So now that I've sufficiently scared you, let me tell you a little bit about what kind of support you'll get. So as far as support, all right, so there's me. I can help you. Now, because each person or each group could be working on something different, it's going to be very difficult for us to spend time in class working on your science fair project. Although we may have some time, that's one of the benefits of having this flipped classroom. But most importantly, you will need to schedule office hours with me. Okay? You'll need to sign up for office hours to sign up so we can spend some time working through your science fair issues. Use each other. You may be working in a team, and I might as well take this opportunity now to tell you a little bit about it. You may work in a team of up to 3 people. You're not allowed any more than 3. The International Science and Engineering Fair limited to 3, but my rule for the class is they have to be from the same class. You have to be in the same period, same class with me, so that you actually have time to collaborate. You have a special time to actually see each other, touch base about where you're going in your science fair project, and you need to select a team leader. And this team leader is going to be the person who communicates with me about your science fair project and who is the one that you're holding most accountable for communicating. Not most accountable for doing the work, but for communicating. But in order to establish a team, there are a couple things you need to do. And the first thing is that you need to write a contract. So for that procedure, come see me. We'll talk a little about what you need to do. But that contract needs to be signed by parents of all team members and each team member before it is approved. But it needs to be in my hands before it gets approved, and I'll look over it one more time. And you still have to hit the same deadline. So if you're working in a team, you need to get going on your contract ASAP, because we have the first deadline coming up very, very quickly. There are also a couple other resources you can use. They're online resources. I would recommend not using science fair websites. They're giving you low quality projects. I know these sites pretty well. I'll know if it's high quality or not, and save yourself the time from the project being rejected. Remember, it needs to be something that you're interested in and you can't find the answer to easily. And it needs to fit our guidelines, and not all these projects do. But there is a website called Um, the Archimedes Initiative. Check it out. There are lots of videos on there about science fair, about doing science, about students doing science, and it's a great resource. We also, what I'm hoping to do is have a researcher mentor for you guys. This is going to be a researcher who video chats with us in class and reviews some of your work. And we'll talk a little bit more about this person, okay? So that's number 3. And then limitations to your project. Okay, so there are a couple of things that you absolutely cannot do. So limitations. So first off, your data needs to be measurable, which rules out quite a few things, or some things rather, I guess. It needs to be measurable, but I think maybe I should do this in a way that that tells you what you cannot do and what you can do as far as subject matter. But I forgot to add measurable and can do statistical analysis too. So you can analyze the numbers, and we'll talk a little bit more about how to do statistics later in the year, but that's quite important. All right, so what can you do and what can't you do? Let's do can't do and can do. All right, so as far as what you can't do, you can't test anything. Can't spell. That has a vertebra. So you can't test any vertebrates. That doesn't mean you can't do anything in the animal sciences, but you can't do it. You can't test vertebrates. You can test invertebrates, like shrimp, snails, squid, that kind of thing. But you cannot test anything that's a backbone, like fish or reptiles, okay? So vertebrates, you absolutely cannot do, and if you want to know more about why, we can talk about that. But this is a school rule. You cannot test vertebrates. You also cannot do anything, and this maybe goes without saying with the vertebrates, but you cannot do any studies on people. You can't ask people questions about psychology or physiology, because there are other requirements that we will not be able to, or you will not be able to meet in this setting. I would urge you away. I'm going to write microbiome on this side, which is really like bacteria projects. And I'll put quotation marks around this, and that doesn't mean that it's not a real thing. I'm just putting quotation marks there because it's not really can't do, but I'd highly discourage you from doing that, because there's a lot of procedure involved in that, and I'm afraid that the procedure actually takes away from the science part of it. You just spend a lot of time doing procedure. Not a bad thing, but you might spend your time doing something a little more interesting, a little more relevant, and mindful of your time. Things that you can do. You can do projects in biochemistry. You can do projects in cellular and molecular bio. You do chemistry. Now, I should point out, though, that in biology, we don't really mind that your project has to be biology related, but some other classes that you take in the future, like your chemistry or physics classes, may say that you need a chemistry or a physics class where relevant, project where relevant. For biology, we're not so particular about that. So you could do chemistry, so you could also do a computer science project. You could do earth and planetary sciences. You could do engineering, electrical, mechanical, materials, um, or bioengineering. Let me see. You can do things in the realm of energy and transportation. Scoot this over. Energy and transportation, environmental management, environmental sciences, mathematics, medicine and health sciences. Again, this is a little bit difficult, but really, when you think about your project, you want to think about the large scope of where does this project fit in, why are you doing it, what part of the scientific field does this fit into, and then you start to narrow down your project into a way that you can measure the effect of something. Again, I'll put microbiome over here as well, even though I put it in the can't do, just so you know that you can do this if you really want to. We've got physics and astronomy as other possible categories. And lastly, plant sciences. Okay, so that's the list of things that you can and cannot do. There may be some more specific ones that we'll talk about, but that's a good enough list for now, okay?